This is Algebra 1, Lesson 9A, Rules for Multiplication of Signed Numbers. If I ask you for the sum of 3 2's, what would that be? Well, sum means addition, so we're going to have 3 2's being added together. And then I could go ahead and find the answer there, 2, 4, 6. What if I asked you for the sum of 2 3's? That would also be 6. Could you write these as multiplications? What would that look like as a multiplication? I'm going to change color here. Instead of 2 plus 2 plus 2, we have 3 2's. So that would be 3 2's, which is also equal to 6. And if you have 3 plus 3, that's 2 3's. I have 2 3's, and that's also equal to 6. How could you model them on a number line? All right, I'm going to go down and look at these on a number line. See if I can scroll out a little bit here. Let's look at the first one, the sum of 3 2's. I'm going to start at 0, and I'm going to get a 2. Okay, that's a plus 2, and then I'm going to go plus 2 more. That's another plus 2, and then a plus 2 again. So we've got a plus 2, a plus 2, and a plus 2, and we end up at 6. Let me do the 3's. All right, now what if I have 2 3's? I'm still going to start at 0, and I'm going to go over to 3, and that's a plus 3. Then I can go from there, 3 more to the right, that's another plus 3, and I still end up at 6. Okay, so we can see, actually let me do one more thing here before we see. Use a number line to find the product of 2 and negative 3 by adding 2 negative 3's. Okay, so let's start at 0, and we're going to go back negative 3. So we're going to go negative 3, and then we're going to go another negative 3. Okay, and we end up at negative 6. Okay, so what have we seen here? We have seen that, and it tells you down here, that if I have a negative 3 and a negative 3, that's the same as 2 negative 3's. And if you add negative 3 and negative 3, we've talked about that before, and we just modeled that here, you get negative 6. And if you do 2 negative 3's, same thing, you're going to get negative 6. Okay? So if you're multiplying and you don't know exactly if the answer is going to be positive or negative, in this situation where you've got a positive number times a negative number, you can see you're going to end up with a negative number. Right? And you can look at the number line and be able to tell why that is. All right, let's go down with one more example. What about if you had negative 3 times 2? Okay, this is a little different. This is like saying I have negative 3 2's. Well, how can I have negative 3 2's? I don't have a way of drawing that on a number line, right? We can't draw that. So the book tells you that the number line isn't helpful for modeling further examples like this, and even signed number division that we'll get to in a future video. But we can use what we have seen so far to summarize with 3 rules. Okay, so we're going to look at these problems here, and we're going to try to summarize what that means so that we don't have to draw number lines when we're multiplying signed numbers. All right, the first section here, you've got a positive times a positive. See, look, positive, positive. They wrote a little differently here. They didn't write the positives, but you can tell it's a positive times a positive. Again here, a positive times a positive. And you can notice that Saxon wants to write those problems a little differently with different notations, so you get used to seeing them in different ways, with parentheses or without. So for A, positive 3 times positive 4 is positive 12. We can model that on the number line as 3 groups of 4 jumps. 3 jumps of 4 to the right would put you at positive 12. 2 times 9 is 18. We know that we could do 2 jumps of 9 to the right, and we'd end up at positive 18. 4 times 5 is 20. 4 jumps of 5 to the right. Okay, so those make sense to us. You've been doing that for a while. Okay, so that's your first situation, a positive times a positive. All right, let's look at number 2. With number 2, all of these problems, you've got a negative times a positive or a positive times a negative. Okay, now we can think of this as 4 groups of -2 because we can't think of it as -2 groups of 4. We don't have a way of modeling that using our number line. But 4 groups or 4 jumps to the left of -2 is going to put you at -8. Here we've got 6 jumps, -2. That's going to end up at -12. And then here, if we do 5 jumps of -3, we're going to end up at -15. So with these, you can see that when you have different signs, right? If the signs are different, here we've got a positive and we've got a negative. Here we've got a positive and a negative. Here we've got this negative and this positive. We ended up with a negative answer. Okay, let's look at group 3. A negative times a negative. Oof, how am I going to do that? How am I going to model that? Well, I can't really model it on the number line. Okay, now one thing that you can use in math to help you figure out something is patterns, okay? Lots of patterns in math. So let's look for a pattern here to see if it can help us, okay? We know how to do this problem because we just did it just a minute ago, okay? 2 -3s, that would be kind of like here where we did 4 -2s. We could model that on a number line. That would just be 2 jumps of -3. So 2 arrows of -3 to the left, you're going to end up at -6. I feel like we would all agree with that. And you can take a time to draw the number line to prove it to yourself. 1 jump of -3, so 1 3 to the left is going to be -3. 0 times anything is going to be 0, right? Now, we don't know what this is here, and we don't know what this is here. But I think we could probably see a pattern. We've got -6, and then it goes to -3, and then it goes to 0. That's kind of a tricky little pattern. Are our values going down or are they going up? All right, let's look at this. Let's take a second to look at this on a number line. Here's -1, 2, 3, 4, 5, -6. Okay, so let's say I start here at -6. And then my next answer is -3. -1, -2, -3. Okay. And then my next answer is 0. Okay. Do you see a pattern now? Our values are going up by 3 and then up by 3. So what should my next answer be? Well, let's go up by 3. 1, 2, 3. Okay, so my next answer should be 3. Okay, I can see these on the number line. So that means, wait a second, a negative times a negative is a positive? Why is that? Well, you can see that the pattern holds. And if you do it again, the pattern's going to go up by 3 again, and 3 plus 3 you can see is 6. You would jump one more to the right. So this is how you end up with a negative times a negative is a positive. This is one way to show it. Okay, so we were able to use what we had learned by using the number line to help us figure out this one with 2 negatives. Okay, so negative, let's go back to A, -2 times -3. We can see, just like here, you're really going to multiply the absolute values of those numbers. Multiply the 2 and the 3, and you get 6. And we know that it's going to be positive because a negative times a negative becomes a positive. Okay, so let's look at B. Absolute value zone, let's just deal with the number first and then decide the sign. 5 times 3 is 15. A negative times a negative is a positive. And then with C, 4 times 5 is 20, and a negative times a negative is a positive.